Okay, let's just dive right into this, because the numbers we're seeing right now are absolutely staggering. Between 2023 and early 2026, the adoption of local AI tools hasn't just grown, it has exploded by an incredible 520 times. That is not a typo. We're talking about a massive leap from around 100,000 monthly downloads for ecosystems like Llama to over 52 million. And this isn't just some niche hobbyist trend anymore. It's being fueled by a very real desire to escape those compounding cloud API costs, ensure absolute data privacy, and run incredibly powerful language models completely offline.
So, welcome to this explainer. Today, our main goal is to completely demystify AI hardware. If you've been itching to build your own local AI machine but honestly feel a bit overwhelmed by the mountain of spec sheets out there, well, you're in exactly the right place. We're going to give you a clear, budget-based roadmap. By the time we're done here, you will know exactly what components you need to target specific local AI hardware budget tiers, all based directly on the most current 2026 data.
Here is a quick look at our roadmap. We'll start with the local AI revolution, establish the golden rule of hardware, and then climb the budget ladder through entry-level, mid-range, high-end, and pro setups, before wrapping up with the Apple Silicon wildcard.
All right, part one, the local AI revolution. The economic contrast we're dealing with here is just wild. If you're a power user, or maybe a team running heavy API workloads, leaning on cloud AI could easily run you over $2,250 every single month. It is a compounding linear cost, and on top of that, you're sending all your proprietary data to external servers. Now, local AI, that operates on a step function cost. You pay for the hardware exactly once, and your marginal inference cost basically drops to zero. You're effectively just paying for the electricity to keep the lights on. Plus, you get 100% offline privacy.
Moving right along to Section 2, the golden rule of hardware.
So what is the single biggest bottleneck? The answer is VRAM, or video RAM. The easiest way to think about VRAM is to picture it as the workbench for your AI models. Look, it literally does not matter how incredibly fast your processor is. If the AI model's weights cannot physically fit onto that workbench, the system has to offload the work to your standard system RAM. And when that happens, it introduces a catastrophic bottleneck and your performance just grinds to an absolute halt. VRAM capacity is, without a doubt, the single most critical variable you have to account for. Thankfully, because of modern 4-bit quantization, which is honestly like magic, shrinking a model's memory footprint by 75% with barely any quality loss, we know exactly what size workbench you need. So if you want to run 7 to 8 billion parameter models, you'll need to target 8 gigabytes of VRAM. Jumping up to 14 to 32 billion parameter models pushes you into that 12 to 24 gigabyte territory. And if you want to run those massive 70 billion plus parameter enterprise models locally, you are looking at a minimum of 24 to 48 gigabytes of VRAM.
All right, Section 3, entry-level and mid-range builds. Let's start climbing the ladder.
We are kicking things off at the incredibly accessible $600 to $1,200 price point. This is our entry-level budget tier, and it's directly targeted at beginners, students, or really anyone looking to learn and run local coding assistants without totally breaking the bank.
Now, here's your ideal starter setup. The absolute MVP of this tier is the RTX 4060 Ti. Depending on whether you grab the 8GB or the 16GB version, this card is just the perfect starter engine. You pair that with a Ryzen 5 7500F CPU, which is going to give you great single-thread performance, and 32GB of DDR5 RAM. Honestly, it's wild how much AI horsepower is packed into a budget card today compared to just a few years ago. This specific combo will easily handle your 3 to 8 billion parameter models like Llama 3.18b or Mistral 7b, running them smoothly right on your desk.
Stepping it up, we land in the $1,800 to $3,200 range. This is widely considered the sweet spot. For about 90% of local AI use cases, this tier perfectly balances performance and value. It's fantastic for advanced coding, content creation, and small business automation.
For the mid-range specs, you're anchoring the build with the RTX 5070 Ti, and here's where we get a really nice jump up to a solid 16 gigabytes of VRAM, meaning a significantly larger workbench. You pair that with a Ryzen 7 7800X3D processor, and that CPU is notable because its 3D V-cache actually provides 15 to 20% better AI performance by reducing memory latency. Throw in a bump to 48 gigabytes of DDR5 system memory, and suddenly you're unlocking the ability to efficiently run complex 13 to 70 billion parameter models using quantization.
But what does this actually feel like in practice? Well, the entry-level tier gets you about 10 to 20 tokens per second on those smaller 3 to 8 billion parameter models, which is roughly reading speed. But making that mid-range investment directly translates into a massive leap. You're pushing much more complex 13 to 70 billion parameter models at a very snappy 15 to 35 tokens per second. It is a noticeable, totally workflow-changing difference.
Okay, let's turn up the heat. Section 4, high-end to professional.
At the high end, we're looking at budgets from $4,000 to $7,000. The foundation here is the formidable RTX 5090 graphics card, which gives you a massive 32 gigabytes of VRAM. Pair this beast with a Ryzen 9 7950X3D CPU and a whopping 128 gigabytes of DDR5 RAM. This is a premium performance tier, allowing power users and developers to run frontier-class 70 billion to 200 billion parameter models, achieving incredibly smooth generation speeds of 30 to 60 tokens per second.
But what if you're a research team or a business looking for a real enterprise deployment? For you, the motto is simple: no compromises. You need to run massive 200 to 405 billion parameter models, or maybe serve multiple 70 billion parameter models to different users all at the same time.
That brings us to the professional tier, which starts around $10,000 and scales up from there. Here, you're utilizing multiple professional-grade GPUs, like dual RTX 6000 Ada generation cards, each packing 48 gigabytes of VRAM. You combine those with heavy-duty enterprise CPUs like the Threadripper Pro, and anywhere from 128 to 256 gigabytes of error-correcting ECC RAM. This is breathtaking scale. You're smashing through massive enterprise workloads and pushing 50 to over 100 tokens per second. Just be prepared, it will definitely double as a very expensive space heater for your office.
And finally, Section 5, the Apple Silicon Wildcard.
Let me pose a question to you. What if your specific research or workload absolutely requires you to run a 400 billion parameter model? On a traditional PC, how could you possibly get 512 gigabytes of VRAM without buying a massive rack of 10 expensive dedicated graphics cards and stringing them all together? Well, this is where Apple's architecture completely flips the script. You see, traditional PC discrete GPUs face a hard VRAM capacity wall, but Apple Silicon uses a unified memory architecture. On a machine like a Mac Studio, the GPU is allowed to directly access massive amounts of system RAM, sharing up to 512 gigabytes. This allows you to host frontier-class models on a device with a standard desktop footprint, completely sidestepping that traditional PC capacity wall we just talked about. However, it is absolutely crucial to remember this: memory bandwidth matters a lot more than raw compute when it comes to token generation speed. While Apple Silicon offers unmatched memory capacity, traditional high-end PC discrete GPUs still win on memory bandwidth. A high-end discrete GPU is going to generate text much faster because it can read the model weights quicker, even if it can't hold as large of a model overall as the Apple system. It is a really fascinating trade-off between total capacity and raw generation speed.
So, we've climbed the whole hardware ladder today, from a $600 starter setup all the way to a unified memory Mac Studio and a multi-GPU enterprise rig. The question I want to leave you with is this: when you really evaluate your specific use case, your need for privacy, and your budget, will you build an entry-level assistant, or are you going for a professional powerhouse? The roadmap is clear, the software is more than ready, and the choice of exactly how you escape the cloud is entirely up to you. So, what's it going to be?